Hello, my name is Adam Attig with Emerson, and today I'd like to introduce you to our new Crosby J-Series Bellows monitoring technology, which provides a unique solution improving safety, reliability, and environmental compliance. Pressure relief valves with bellows are necessary when variable or high built-up back pressure are seen at the valve's outlet, such as in a flare header system. The bellows prevents back pressure at the outlet of the valve from affecting set pressure and ensures the valve opens at its intended set point. In addition, the bellows serves as a barrier to isolate critical valve components inside the bonnet chamber from exposure to corrosive media. Furthermore, in the event of a bellows failure, the PRV bonnet vent must remain open to atmosphere to ensure pressure is not accumulated in the bonnet, which could alter the valve set pressure. With over 30,000 service records across several different industries and including multiple PRV brands, it is estimated that up to 6% of all bellows in operation are damaged and potentially compromising the critical safety that overpressure protection provides. Here's an example of a common bellows failure. Bellows failures may pose serious challenges to a plant's reliability, productivity, safety, and environmental compliance. A common challenge related to reliability are unintended releases, which may indicate issues with the process and lead to unplanned and costly service outages. Productivity is another challenge, as production and energy losses related to a release can be costly and undetected for long periods of time. Environmental compliance is also a concern, as releases can lead to costly fines and lawsuits, as well as non-compliance with government regulations and ESG programs. Finally, safety is a major challenge, as many releases go undetected and unreported and can be considered near-miss events, compromising the effective operation of the PRV and system.
Hi, my name is Ricardo Garcia with Emerson, and today I'll be demonstrating the bellows monitoring technology for the Crosby J-Series valve. As part of our monitoring solution, we've included a backup piston and an adapter mounted to the disc holder. The guiding clearances of the piston are held to a minimum with a machined labyrinth seal around the piston, reducing the flow between the piston and the adapter. In the event of a bellows failure, the seal minimizes any flow through the bonnet vent to atmosphere, reducing fugitive emissions significantly, as well as maintaining the balancing effect of the valve. The additional component of our monitoring solution is a pressure transmitter plumbed into the piston bellows chamber. In the event of a bellows failure, the pressure in the bellows chamber will rise, and this change in pressure will be sensed by the transmitter and inform the user of the event. This bellows monitoring technology is highly sensitive, and it is capable of detecting bellows failures down to the thousandth of a square inch. For this demonstration, we have simulated the effects of back pressure on this J-Series valve using compressed air, and have made a pin-sized hole on the bellows to this valve to simulate a typical bellows failure. A Rosemount 2051 pressure transmitter has been added to sense the increased pressure past the balancing piston. Knowing the increased pressure as well as the piston clearances and process fluid data, we can calculate the volumetric flow that is being released as a result of the bellows failure. Next, we will illustrate the added benefit of the balancing piston by showing the reduction of fugitive emissions with a flow meter on the bonnet vent. On the left, there is an example of a valve with a ruptured bellows that does not utilize the balancing piston. In this scenario, adding 5 psi of back pressure to the outlet of the valve, you can see that the flow meter reads 7,000 cubic centimeters a minute. The example on the right shows the same valve with the balancing piston installed and under the same psi of back pressure. You can see the fugitive emissions through the bonnet vent have been reduced to 1,000 cubic centimeters a minute. As we have reviewed today, bellows monitoring helps customers improve their reliability, safety, and productivity by providing instant notification of a bellows failure, reduced fugitive emissions, along with the information needed to calculate volumetric emission releases. Thank you for your time today.